Okay, so let's talk about local extrema. You see the term extrema? It is plural for extremum. And all that extremum means is that that's either a maximum or a minimum value. Okay, so these are the extreme values. What is the maximum of this function? What is the minimum of this function? Which I'm sure you can see why in a business context, let's say we're dealing with a profit function, we want to find where our maximum profit occurs, right? That would be a very useful thing to know. And so the question is, how can we do that? Well, we can do that by learning how to identify local extrema. So here's the definition of local extrema, and then we'll look at a couple of examples. The definition says, let C be a number in the domain of a function f. In other words, we have to actually be able to plug C into the function and get a defined value. Then, 1. F has a local maximum at C if f of x is less than or equal to f of c, c, for all x near c, and then 2, we're going to talk about the minimum. Okay, so f has a local minimum. F has a local minimum at C if f of x is greater than or equal to, come on, there we go, f of C for all x near C. And then basically a local max or a local min, those two things, local max, local min, those are what we mean by local extrema. Okay. And that's the definition. The definition is just a really fancy way of saying the thing that we have a pretty decent intuitive grasp of. For example, if I have, let's say, a downward facing parabola, and I want to know where's my extremum, well, I mean, here it is, right? It's at the vertex. That's my maximum. Well, why is that my maximum? Because at all values near that maximum, the function is less than or equal to that maximum value. That's the definition of what a maximum is. Everything else is less than it. Similarly, if x has a local minimum at C, everything else except for the value at C has to be bigger for all x nearby, right? So if we had, let's say we had an absolute value function, right? And again, here's my vertex. Okay, well, that's my minimum. And I can see that that's my minimum because everywhere else, aside from at f of c, that function is bigger than the value at the vertex. And so that's my minimum. Okay, so that's the idea with local extrema. And now what we want to talk about is how can we find those extrema? So to look for our extrema, we can take a look at a couple of things. One thing is the critical numbers. If f has a local extremum at a value, that value has to be a critical number. Okay, so that's the way that we're going to go looking for local extrema, is by looking at critical numbers. And then in the very next video, we're going to talk about the first derivative test. The first derivative test is the thing that helps us locate the location, helps us pinpoint where are these extreme values, where are our local max and or local minimums occurring.